Okay, today I'll see cycloconverter. Yesterday I had told what do you mean by cycloconverter? Anyone? What is cycloconverter? Cycloconverter is a device which converts one frequency to another without change in the magnitude of voltage. Okay. Cycloconverter is a device which converts one frequency to another without change in the magnitude of voltage. Here, input frequency is fixed in cycloconverter. Output frequency is variable. Suppose input frequency is 50, output frequency is 75. What is this type of cycloconverter called? The cycloconverter, what you will call this type of cycloconverter? If output frequency is greater than input frequency, what will you call it as? Step up cycloconverter. If output frequency F0 is less than Fin, then it is called step down cycloconverter. If output frequency is less than the input frequency, it is called step down cycloconverter. If the output frequency F0 is greater than input frequency, that is called step up cycloconverter. Now we'll see both step up and step down cycloconverter. There are two configurations given in this slide. Both circuits can be used both as step down. This is the first circuit, this is the second circuit. First, 1 minute. First circuit is called Midtap cycloconverter. This first diagram is the Midtap cycloconverter. Second one is bridge cycloconverter. Second one is bridge type cycloconverter. So let us see first one. Then we'll go to the first circuit can be used both as step up and step down cycloconverter. Second circuit can also be used both as step up and step down cycloconverter. But the operation is different for step up and step down cycloconverter. Let us see first of all bridge type cycloconverter. This is the mid type cycloconverter. Why it is called mid type cycloconverter means the center point of secondary. This is the secondary winding. Center point of secondary winding is connected to load. That's why it's called mid tap. At the midpoint of secondary winding is connected to load. Is called mid tap cycloconverter. This is the primary winding. This is the secondary winding. Secondary winding midpoint is connected to load. Here we are using AC. AC voltage is the circuit symbol of AC voltage source. Output across the load is also AC. But here what you are doing, suppose if the frequency of this voltage source is, if the frequency of this voltage is 50 hertz, in step up cycloconverter it will be greater than 50 hertz. Here 50 hertz frequency supply. Here across the load we will get output voltage. The frequency of that output voltage, let us take 100 hertz. Then output is frequency is greater than input frequency, which is called as step up cycloconverter. Okay. So observe the circuit diagram. First we'll discuss this circuit. This circuit can be used both as step up cycloconverter and step down cycloconverter. Here we are having four thyristors P1, N1, P2 and N2. P1 and N1 are connected in anti-parallel. See, if anode is here, anode is this side. P1 and N1 are anti-parallel. P2 and N2 are anti-parallel. Observe the circuit. Observe the circuit for Midtap cycloconverter. Now see here in the circuit, P1 N1, P2 and N2. Now I'll go first. I will explain this circuit as step-up cycloconverter. First, I'll explain this circuit as step-up cycloconverter. Step-up cycloconverter means the output frequency is greater than the input frequency. Here, this is the voltage source. This is the source voltage source Vs. Vs is having one frequency, and V0 is also having one frequency. Across the load, we will collect output voltage. V0 is also having one frequency. The frequency of this output voltage should be greater than the input frequency. Should be greater than input frequency in step-up cycloconverter. Now I'll explain the operation of this circuit. See here, this is the voltage source Vs. For positive cycle, this will be plus and minus. For negative cycle, this will be minus and plus. This voltage source is connected across primary winding. Primary winding is connected across the voltage source. Then what is the voltage across this primary winding? Vs. Here I am using the transformer as 1:1:1. Same windings we are using. Suppose if you are having 10 turns here, here also 10 turns, here also 10 turns. 1:1:1 ratio. So this voltage source is connected across this primary winding. Then what is the polarity here? This will be plus, this will be minus. See here, plus and minus. But here we are taking center tapping of the load at the center point of the charge. From here to here it will be, if this is positive terminal, this plus is connected here. If this is positive terminal, this will be negative terminal. Again adjacent to negative is positive, again it will be negative. Positive and negative. Here this is positive, this will be negative now. During positive cycle of the supply voltage. What do you mean by positive cycle? From here to here, from 0 to pi. From here to here, this is positive cycle. From here to here, this will be negative cycle. One cycle means one positive and negative is called one cycle. First, I am discussing about positive cycle from 0 to pi. 0 to pi positive cycle. For positive cycle, what is the polarity? This is the polarity. For positive cycle, I am saying minus and plus for positive cycle. If this is minus and plus, what is the polarity here? Plus minus. Here also plus and minus. Suppose if this is plus, among these two thyristors, which one is forward biased? The forward bias?
P1, sir.
P1. Okay. P1 is the forward biased. Now N1 is reverse biased. N1 is open. Now if it is minus here, among these two, which one is forward biased?
N2.
Among which one? N2. Okay. N2 is forward biased. That means during positive cycle of the supply voltage, P1, N2 are forward biased. N1 and P2 are reverse biased. Please remember this point. During positive cycle of the supply voltage, only P1 and N2 are forward biased. Now they are forward biased, P1 and N2. If you are not giving firing pulse to P1 and N2, they are in open circuit only. Even though they are forward biased, P1 and N2. If you are not giving firing pulse to P1 and N2, they are They are open circuit. Anyway, N1 and P2 are reverse bias, they are open circuit. Now concentrate only on P1 and N2 during positive cycle because they are forward biased. If you give firing pulse in between gate and cathode of the SCRs for P1 and N2, they will come into on state. If you are not giving firing pulse, they will be in open circuit only. Now during positive cycle, I am considering. See here. Now I am considering the positive cycle. This is positive cycle from 0 to 5. I am giving firing pulse to P1 here at 0 degree. At 0 degrees, I am giving firing pulse to. See here P1 N2, P1 N2, P1 N2. Now observe here. During positive cycle from 0 to pi, I will give firing pulse alternatively P1 and N2 because these two are forward biased. We can't give firing pulse to N1 and P2 because they are reverse biased. Now I am giving firing pulse to P1 at which point at origin I am giving firing pulse to P1. If you give firing pulse to P1, P1 is on here at 0 degrees. At this point, I am forcibly switching off P1 with the help of commutation, forced commutation circuit. I am forcibly switching off P1. When you are switching off P1 at the same instant, I am giving firing pulse to N2. See here. After switching off P1, I will give firing pulse to N2. Then N2 will come into on state. So I am discussing about during positive cycle. What is the positive cycle? See here. From 0 to pi. From 0 to pi, I'll give firing pulse alternatively. I'll give firing pulse to P1 and N2 alternatively. When P1 is given firing pulse, it will come in the positive cycle. When you give firing pulse to N2, the output voltage is in the negative cycle. I will tell why P1 for P1 will get positive side, for N2 will get negative side. Here from 0 to pi, the polarity will not change. It will be same polarity. This polarity plus and minus will not change up to pi. So here we can give firing pulse to P1 and N2. When you give firing pulse to P1, I'm not giving firing pulse to N2. I'm giving firing pulse only to P1. Now current flows like this from minus to plus P1 load again negative positive like this P1 then I not then I not in the load like this. This is the current direction when we give firing pulse to P1. So now forcibly switch off this. Where will switch off this P1? Here I am switching off P1. At the same time I will give firing pulse to N2. See, now I am switching off P1 and I am giving firing pulse to N2. Current always flows from anode to cathode only. That's why it is playing. Now if you switch on N2, what is the current direction? From anode to cathode. Negative, positive load. Current direction. Load lo ఏమైంది? What happens to the current direction in the load? When P1 you give firing pulse, current is flowing in this direction in the load. When N2 is on state, current is flowing in this direction in the load. That means polarity is changed in the load. Previously, when current is flowing like this will be plus and minus. Now, when current is flowing in the reverse direction, this will be plus and minus. That's why since polarity is changed, we will get negative cycle. Again, forcibly switch off N2 here. Again P1. Again N2. Again P1. Again N2. So up to half cycle we have discussed. Any doubt up to this? Now come to negative cycle. From pi to 2 pi, it will be negative cycle. If it is negative cycle, the polarity is changed. Now this is minus and this will be plus. Now here it is minus, plus, minus, plus. If it is minus, which one is forward biased among these two? If it is minus, which one is forward biased among these two thyristors? Is
N1, sir.
okay, N1 here. Among these two, if it is positive, among these two, which one is forward biased?
P2.
P2. That means from pi to 2 pi, N1 and P2 will be forward biased. P1 and N2 are reverse biased. See in this waveform. From 0 to pi, P1 and N2 are forward biased. From pi to 2 pi, P2 and N1 are forward biased. P2 and N1 are forward biased for the entire negative cycle. This is in minus and this will be positive. Now give firing pulse to P2. See here. Now I am giving firing pulse to P2 here at 5. After that, I will forcibly switch off this and I will give firing pulse to N1. P2 and N1 alternate. Again P2, N1, P2, N1. Now observe the diagram. Now if we give firing pulse to P2, what is the current direction? In this direction. Suppose if we give firing pulse to N1, what is the current direction from anode to like this? When P2 is on, current is in this direction, and N1 is on, current is in the reverse direction. That's why the polarity is changed here. P2, N1, P2, N1, P2, N1. After this, again positive cycle. Why they are taking reflection of this? For drawing easily. For drawing the waveform, it will be easy. If it this is the actual sinusoidal waveform. And what is this waveform? Reflection of the upper wave. Reflection. They are taking why they are taking reflection means for drawing the output voltage. For drawing output. Like this, we'll get output voltage. This is the output voltage. Input is sine wave. Output, what is the output? This is the output. Within a so total time period of input is 1 by Fs. Input means one cycle. From here to here, half cycle. From here to here, half cycle. Total one cycle. One cycle is Ts. Time period is inversely proportional to frequency. This is for input. Now see the output voltage. For output, what is the frequency now? This is one positive, one negative. One positive, one negative. One positive, negative. One positive, negative, positive, negative, positive, negative. Here three cycles, here also three cycles. Total how many cycles? 1, 2, 3, 4, 5, 6 cycles. For an input frequency is Fs. Input time period is Ts. Now what is the time period? Now what is the time period of one cycle from here to here? ఇక్కడ నుంచి ఇంతవరకు టైం పీరియడ్ ఏమవుతుంది? ఇది టోటల్ పీరియడ్ T అయితే what is the time period of output? One positive, one negative you take. What is this time period now? Anyone? Time period ఏమైంది? ఎన్ని సైకిల్స్ ఉన్నాయి ఇక్కడ అవుట్పుట్ సైకిల్స్? దిస్ ఇస్ ద అవుట్పుట్ వోల్టేజ్. ఫర్ అవుట్పుట్ వోల్టేజ్ 1 cycle, 2, 3, 4, 5, 6. That means time period is reduced by 6 times. Take from here to here. Otherwise from here to here. This positive and negative. See, T naught is the output time period. 1 by F naught is the output frequency. Your T naught is equal to T by 6, Ts by 6. Time period is reduced by 6 times. This is 1 to 6 cycles are there. For an input of one cycle, we are getting 6 cycles output voltage. V naught is output. This is the output. Thick line. చూడండి thick line output మీకు ఇక్కడ. So 6 cycles వస్తున్నాయి మీకు output cycles. So what is the time period of one output cycle? T by 6. If it is T, what is the time period? T by 6. Time period is reduced by 6 times. Frequency increases by frequency any times increase అవుతుంది?
1 by 6.
Time period reduced by 6 times. Time period frequency is inversely proportional to time period. Frequency increases by 6 times. 6f. Okay. Here a time period is inversely proportional to frequency. Make time period 6 times reduce అయితే frequency will be multiplied by 6. Okay. Frequency is increased by 6 times. That means your output frequency is greater than the input frequency. Input frequency is Fs. Output frequency is 6 into Fs. 6 into Fs. That means this is the step-up cycloconverter. See, waveforms for step-up cycloconverter. Any doubt in this? Bridge type cycloconverter. Can anyone explain this circuit and waveform what I have explained now? If anybody want to explain, you tell me. I will make you as the host so that you can explain.
Sir, explain second diagram, sir.
Second diagram. This one.
Yes, sir.
This one I have not started it. I have explained only this one. Later I will explain. First, if you understand this one, it is very simple. First, you explain this diagram and waveform. Later, I will go to this. Can anyone explain? If anybody want to explain, you tell me. I will make you as the host so that you can operate the diagram and waveform, and you can explain. First circuit diagram and waveform. Anyone? You can raise
Sir,
your hand.
how the current go to load, sir?
How the current will go to load. Okay, I will explain. See here. First, discuss about positive cycle. If it is positive cycle, this will be plus, this will be minus from 0 to pi. From pi to 2 pi, this will be minus and this will be plus. During positive cycle, this will be plus and minus. P1 and N2 will be forward biased during positive cycle because positive is connected to anode here and negative is connected to cathode. That's why P1 and N2 are forward biased from 0 to pi. Now alternatively, I will give firing pulse to P1 and N2. At a time, I am not giving firing pulse to P1 and N2. First, I will give firing pulse to P1. Next, I will give firing pulse to N2. Let us take I am giving firing pulse to P1. When you give firing pulse to P1, what is the current direction? From here, negative to positive through P1, through load, again like this. Current will not flow in this two because I have not given, this is already reverse bias, we are not giving firing pulse to N2. Current is flowing minus to plus, P1, load, again P1 like this. Okay, now see the waveform. I am giving firing pulse only to P1. Current is flowing, voltage will get like this up to here. Up to here will get. At this point, what I am doing, I am forcibly switching off P1 with the help of commutation circuit, and I will give firing pulse to N2. చూడండి ఇక్కడ పాజిటివ్ లో వచ్చింది P1 ఆన్ అయినప్పుడు నెగిటివ్ N2 లో వచ్చినప్పుడు నెగిటివ్ వస్తుంది. Why? Polarity is changing in the load. See, now I will switch off this. I will give firing pulse to N2. Now how the current will flow? Minus to plus, load, N2, again negative, positive, load. When P1 is on, what is the current direction? This is the direction in the load. When N2 is on, what is the current direction? In this direction. Current direction in the load is changed. Since current direction in the load is changed, the polarity is changed. Again forcibly switch off this. Again switch on P1 here. Then again P1. Again forcibly switch off P1, N2. When P1 is on, we'll get positive cycles. When N2 is on, we'll get in the negative cycles. Why in the negative cycles means in the load current direction is changed. When P1 is on, current is flowing in this direction. Let us take it as positive in this direction. When N2 is on, current is flowing in the reverse direction in the load. That's why I'm taking the negative polarity. Polarity comes in the negative. So first you draw one sine wave here. Then you draw the reflection for this. So that if you draw the reflection, you will easily get P1. This is the output voltage during N2. The thick line, the thick line is the output voltage. Okay, this thick line is the output voltage. Like this. So time, if you take one cycle of the input is this one cycle, positive sine wave from here to here. This is one cycle TS. For one cycle time period, here time period is reducing to 6 times. One positive negative you take for output voltage V0. Time period is reduced by, otherwise positive one positive and one negative. See here, T not means output. your time period is reduced by 6 times. Then automatically frequency increases because time period is inversely proportional to frequency. Time period reduce అయితే మీకు one cycle ని automatically 6 cycles ఉన్నాయి, 6 output cycles. That means frequency is increased by 6 times. So that's why it is called step-up cycloconverter. Any doubt? Similarly, once if you come to negative cycle from 5 to 2 pi, pi to 2 pi, which thyristors are in on state? This will be during negative cycle, this will be minus and plus. What are the thyristors?
P2 and N1.
P2 and N1. Similarly, when P2 is on, current is flowing in the load in this direction. When N1 on, current direction is reversed in the load. That's why for P2, we'll get positive. P2, for all P2s, we'll get positive. For all N1s, we'll get negative cycle. Like this. This is the center tap transformer or mid tap transformer. There are two types of cycloconverter. One is mid tap and the one is bridge type. This is the bridge type. Now we have discussed about the center tap. This circuit can be used as step up cycloconverter and step down. I have discussed only step up here now. The same circuit can be explained for step down also. Once if I come to step down, I'll explain that. Similarly, this circuit can also be used as step up transformer and step down transformer. Any doubt in the first circuit? First
No,
circuit.
sir. Sir,
Tell me.
when the current is flowing from P2 and N1, sir, will the polarity of the supply will change, sir?
Supply polarity is already changed here. See, this is the input supply frequency from here to here, 0 to pi, positive cycle. From pi to 2 pi,
Okay,
the
sir.
polarity is changed here. See here, already it is changed, input polarity cycle. Because AC, this is input is AC,
Yes, sir.
output is
Yes,
also
sir.
AC. Okay.
Yes, sir.
Okay. Still any doubts? Okay. For today, you read this circuit at home in your textbook. Tomorrow I'll explain clear this circuit. Otherwise, I will explain now here. See, bridge type cycloconverter. We are having here how many P1 and P2 are positive thyristors? Only two. N1 and N2 are negative thyristors. Only two thyristors. Now here in bridge type, they are taking P1, P2, P3, P4. Similarly, N1, N2, N3, N4. ఇక్కడ చూడండి యానోడ్ ఈ P1 థైరిస్టర్స్ అన్ని యానోడ్ డౌన్ సైడ్ ఉన్నాయి. ఈ N1, N2 ఇవన్నీ ఈ సర్క్యూట్ ని ఎగ్జాక్ట్ గా ఇక్కడ రివర్స్ కనెక్ట్ చేయండి. విల్ గెట్ N1, N2, N3, N4. ఒక మిర్రర్, టేక్ one mirror and connect this entire circuit in the reverse direction. Load is in between these four thyristors. In between these four thyristors, load is here. P1 ఇక్కడ ఉంటే N1 ఇక్కడ ఉంటుంది. ఇక్కడ చూడండి P1, P4 ఇక్కడ అవుట్ సైడ్ ఉంది. N1, N4 is also outside. Inside ఏముంది P2, N3. Here also N2, N3 inside. P1, P4 reverse here, N1, N4. P2, P3 similarly N2. How we will connect this thyristors? See, P1, P2 cross, P1, P2, P3, P4. Similarly here also N1, N2, N3, N4. This is the bridge type. In between the positive side and negative side, we are having load. In between positive side and negative side, we will have the load. Now how we will connect the source? You see, this is the source. Here also we are having source. E positive connect in between P1 and P4. E positive terminal, e point in this kochi in between P1 P4 connect. Same positive terminal is connected here to in between N1 and N4. See the circuit. This positive terminal is connected in between P1 P4 point A. Here this is point A, N1 N4. Same positive terminal he connected here also in between N1 and N4. Now come to negative terminal. Negative terminal is connected in between P2 and P3. Same negative terminal is connected in between N2 and N3. ఇక్కడ P2, P3, ఇక్కడ N2, N3. Circuit diagram is clear. Observe the circuit diagram. చూడండి circuit diagram. If you draw the circuit at home, it will be clear to you. Okay, now I'll explain the operation of this circuit. You see. Now during positive cycle, this will be plus minus. Negative cycle, this will be minus and plus. Positive cycle means from 0 to pi. Positive cycle, it is 0 to pi. Now this positive, at A we are having positive terminal. Here also we are having positive. Here it is positive, it will be negative. This is the positive terminal at A. Negative terminal is here at X. ఇది పాజిటివ్ టెర్మినల్, ఇది నెగిటివ్ టెర్మినల్ అయినప్పుడు what are the thyrist among these four thyristors, which are forward biased, which are reverse biased? See only here, positive, negative. If it is positive among these two, which one is forward biased? P1, P4 ki ikkada positive terminal అయినప్పుడు. During positive cycle, this is plus and minus. Now this is plus. That means here point A plus is there. This negative. Negative is here at X. Among these four, which one is forward biased? Suppose let us take positive here. Positive is connected to P1, P4. ఈ P1, P4 లో ఏది forward bias ఇప్పుడు?
P1, sir.
P1 is forward biased. Okay. If it is negative among these two, which one is forward biased? ఇది negative అయితే, negative is connected to cathode. This will be forward biased. Negative is connected to anode, means this will be reverse biased. Okay, now P1, P2 are forward biased during positive cycle. Positive cycle, if it is positive, it is negative. Positive is connected to anode. This is forward biased. Positive is connected to cathode. This is reverse biased. Similarly, negative is connected to cathode. This is forward. This is reverse. Now during positive cycle, in the positive group, P1, P2 are forward biased. Now come here. This is positive. This is negative. Among this, which one is forward biased? If it is positive among N1 and N4, which one is forward biased?
N1, sir.
N1. Here
N2.
N2. That means P1 during positive cycle, P1, P2 forward biased, N1, N2 are forward biased. Note down in your notes if you are having notes. During positive cycle in this circuit, P1, P2, N1, N2 are forward biased. If you are having pen and paper, you can note down this. This point is very important for operation. During positive cycle, P1, P2, N1, N2 are forward biased. Now see here I am giving firing pulse to P1 and P2 at a time. Bridge type lo only P1 ki icharu. In place of P1, you note down P1, P2 will give forward, will give firing pulse. Here we will switch off P1, P2, will give firing pulse to N1, N2. Now see the direction of current in the loop. Now we can give firing pulse only to P1, P2 and N1, N2. So first I am giving firing pulse to P1 and P2. I am not giving firing pulse to N1, N2. If you give firing pulse to P1 and P2, what is the current direction you see? Negative to positive through P1, through load, through P2, again into the source. Note down the path if you are having pen and paper. Minus to plus, then through P1, then through load, then through P2, then again into source. Is it clear? This is the current direction. When P1, P2 are on, if you give firing pulse to P1, P2. Now I am forcibly switching off this P1 and P2. Now P1, P2 are off. Now I'll give firing pulse to N1, N2. I'll give firing. మీకు P1, P2 ఆన్ అయినప్పుడు what is the current direction in the load? Downward. Remember this. P1, P2 on లో ఉన్నప్పుడు current direction downward ఉంది. Now see, I will switch off P1, P2. I'll give firing pulse to N1, N2. When you give firing pulse to N1, N2, what is the current direction you see? Minus to plus through N1, through load. Current always flows from anode to cathode only. Through N2, again into source. Like this. This is the current. మీకు N1, N2 ఆన్ అయినప్పుడు కరెంట్ డైరెక్షన్ ఎలా ఉంది? లోడ్ లో అప్వర్డ్ ఉంది, అంటే పొలారిటీ చేంజ్ అయింది. సి ప్లస్ మైనస్ టు ప్లస్ త్రూ N1, through load upward direction, through N2, again into source, like this. Okay, that means current direction in the load is changed. So from here to here, this is one positive, sorry, this from here to here, this is positive cycle. From here to here, this is positive cycle. Here P1, P2 on అయినప్పుడు current direction load ఒక direction అయితే, here N1, N2. In place of P1, you write down P1, P2 for bridge type. Here P1, P2, N1, N2. Again P1, P2, N1, N2. P1, P2, N1, N2. Okay. Now positive cycle is completed. From 0 to pi positive cycle. Now come to negative cycle. If you come to negative cycle, the negative cycle. In the negative cycle, this polarity is changed at the source. This will be minus, this will be plus. Now here this is minus. This is minus means now this is minus, this is plus. Now P1, P2 are reverse biased. P3, P4 are forward biased. Similarly here N3, N4 are forward biased. If this polarity is changed, automatically P3, P4 are forward biased, N3, N4 are forward biased. Now if P3, P4 are forward biased, now this is minus and plus. Now current flows through P3, current direction in the load is downward. P4, like this. This is the current direction. N3, N4 on అయినప్పుడు current direction upward ఉంటుంది. That means here in place of P2 write down P3, P4. Here you write N3, N4. One second. Is it clear? In the negative cycle, do one thing. For bridge type, 2 thyristors will be on. Here you write down P1, P2. Note down in your notes. P1 దగ్గర P1, P2 రాయండి. N2 దగ్గర N1, N2. Again P1, P2, N1, N2. P1, P2, N1, N2. In place of P2 write down P3, P4. Here N3, N4. P3, P4, N3, N4. P3, P4, N3, N4. Waveform is same both for this circuit and this circuit. Both are step-up cycloconverter. Now I have discussed one step-up cycloconverter. So the waveform is also same and frequency is increased by 6 times. In bridge type, we are having 2 thyristors will write. Here P1, P2, N1, N2. P1, P2, N1, N2. P1, P2, N1, N2. Here P3, P4, N3, N4. P3, P4, N3, N4. P3, P4, N3, N4. Is it clear? The circuit and waveform? If you are having any doubt in this circuit and waveform, you can ask me. చూడండి. So today I have completed step-up cycloconverter. Tomorrow we will discuss step-down cycloconverter. Doubt ఏమన్నా ఉందా సర్క్యూట్లో ఇక్కడ? డౌట్ ఉంటే అడగండి. ఏం లేదు, మీ లోడ్లో పొలారిటీ చేంజ్ అవుతుంది. P1, P2 ఆన్ ఉన్నప్పుడు కరెంట్ డౌన్వర్డ్ ఉంటుంది. N1, N2 ఉన్నప్పుడు కరెంట్ అప్వర్డ్ డైరెక్షన్ లో ఫ్లో అవుతుంది లోడ్. That's why I am taking here polarity is changed here. And the output also. Input is AC, output is also AC. But frequency is changing here, that's all. Without change in the magnitude of voltage. Only frequency change. Frequency is increased. Time period is meaning means time period reducing means frequency will increase. Because frequency is inversely proportional to time period. That's what you have to remember. What I am doing here, I am reducing the time period of cycle. Input time period is TS. From here to here, 1 cycle. Output is only from here to here, positive, negative take. time period is reduced by 6 times. Automatically frequency increases by 6 times. Observe this. I'll take the attendance meanwhile.
What is the value of resistance in practical terms? Value of resistance RS. Here, practical, what I am asking is practical. It should be presented RS, right? So, RS value is presented in practical. Correct? Practical or practical. Practical. What is the value of resistance? Value of resistance in practical RS. Right? Internal resistance. You will understand from value of resistance in practical.
Okay, I have taken the attendance. Any doubts you are having? You read it at home so that tomorrow if you are having doubts,
Is there any component presented here?
someone is asking anybody is having doubt in this? Okay, read it at home. Textbook also I have shared with you. Yesterday I have posted the textbook in WhatsApp group. Read the textbook. I will post this cycloconvert also in group so that tomorrow we'll discuss.